Yeah. Yeah.
Good afternoon, everyone. This is Renee, Katie, and Queenie. Today we'll be talking about transform boundaries.
So to start off, here's a preview of the topics we will be covering today. Plate tectonic basics, transform boundaries, the San Andreas fault system, and earthquakes caused by the San Andreas fault.
To start off, we'll be talking about plate tectonics basics and giving you some background information on them. As you can see from this picture, which is in scale, Earth's lithosphere is the uppermost layer of the Earth, aka the crust, fractured into a series of plates, and these plates are called the plate tectonic. There are three types of plate boundaries: divergent, convergent, and transform. The image on the right is an example of how the boundaries will. Starting from the top, the divergent boundary are when two plate tectonic move away from each other, when the magma rises from the Earth's mantle to surface, creating a new oceanic crust. An example of a divergent boundary is a mid-ocean ridge, which is the example. And conversion boundaries occur when two plates collide and one plate eventually slides beneath, which call it a subduction. And the last plate boundary, which is the one we'll be talking about, it is the transform boundary. Transform boundaries occur when two plates lie slightly past each other, and we will go in depth about it on the next few slides. So, what is a fault? A fault is a fracture or a zone of fractures between two blocks of rock. It has been displacement as a result of rock mass movements. There are many different types of faults, including normal faults, reverse faults, strike slip faults, and slight strike fault is a part of transform boundaries.
Okay, now we will be talking more about transform boundaries. What is a transform boundary and how does it work? So transform boundaries occur when plates slide sideways past each other. Transform boundaries have a right lateral slip, meaning the right block is always sliding towards you, while the left block is sliding away. Another way to think about this is that if you're standing on one side of the fault, the other side should be moving horizontally to your right. This type of boundary is the only boundary that doesn't destroy or add to the Earth's crust by pulling apart or smashing together. Transform boundaries simply just slide past one another. Also, transform boundaries can contain multiple faults. Here's a more complicated version of a transform boundary zone. In this image, we can see multiple faults that all have a general direction going east-west. The transtension caused by the faults can create mountains, hills, a basin or gap, which can be filled by water. So along the faults, you may find streams or lakes. Folds are created by something called transpression, meaning it was made with lots of pressure and compression. The river shifts due to the cut of the fault, which is an example of offsets. We'll be talking more about offsets on the next slide. The sag pond is an example of a basin, which is a gap that can be filled with water. Transform fault zones include strike-slip faults, linear ridges, valleys, offset drainages, local elongate lakes, and ponds. What is an offset? An offset is the horizontal displacement between points on either side of a fault, as shown by the red line in the drawing. Offsets also cause the amount of movement during a faulting event. Where can you find transform boundaries? Most transform boundaries occur at mid-ocean ridges at the bottom of the ocean. The mid-ocean ridge is the range of mountains under the ocean that is caused by a divergent boundary. Ridge systems in the ocean are separated by transform faults, which connect offsets in the mid-ocean ridges. This type of boundary also causes a lot of earthquakes in the ocean. Transform boundary effects. So the grinding action between the plates slipping past each other, at the transformed plate boundary can cause earthquakes, large lateral displacement of rocks, and a broad zone of crustal deformation.
Now we will be talking about the San Andreas Fault System. The San Andreas Fault includes a decent amount of faults involving the San Andreas Fault, Hayward Fault, Maxima Fault, Rogers Creek, Green Valley, the Sargent Fault, Caldera, San Joaquin, and Greenville. What is the San Andreas Fault? So the San Andreas Fault is an example of a transform fault. And this fault separates the Pacific Plate and the North American Plate. And this type of fault displacement is a right lateral strike slip, meaning the right block is always moving towards you while the left block moves away from you. This is also why people say LA will eventually be where SF is, because as you can see from the diagram, LA is in the Pacific Plate while SF is in the North American Plate, and the Pacific Plate moves up while the North American Plate moves down. So eventually, LA and SF will be parallel to each other, and LA could possibly even be where Alaska is in the future. How does the San Andreas Fault produce earthquakes? So the San Andreas Fault ruptures about every 150 years, although it's not always accurate. But how does this happen exactly? So first, the built-up strain breaks the rock along the fault. Next, the plates slip a few feet all at once. Third, the breaking rocks send out waves from every direction. And lastly, the waves will create earthquakes, and the earthquake will be felt in areas around it.
Lastly, we'll be talking about the earthquake that caused by the San Andreas Fault. The two notable earthquakes that you might have heard of, and they're the San Francisco and the Loma Prieta earthquake. First, the 1906 San Francisco earthquake occurred on April 18. Even though it lasted less than a minute, the impact was disastrous. The waves could also be felt from the southern Oregon to Los Angeles. The earthquake also ignited several fires around the city that burned for 3 days long and destroyed nearly 500 buildings in the city. The second earthquake that we'll be talking about, the Loma Prieta earthquake, there were two foreshocks happened around 6 months before the actual earthquake of magnitude 6.9 occurred on October 17, 1989. The earthquake itself lasted around 10 to 15 seconds, but caused a lot of damages, such as people getting killed, injured, and left homeless. So what happened, what could happen if San Andreas Fault create an earthquake? There could be a lot of damages occur if the San Andreas Fault cracks, such as an earthquake of magnitude 7 to 9 will occur. No building will be 100% safe, and 1,800 people will not survive, and 1,600 large fires. And also lots of aftershocks occur, and it costs us $33 billion of damage.
Okay, so let's recap what we went over today. First, we went through plate tectonic basics, which gave you quick background information on plate tectonics, such as the 3 different plate boundaries, divergent, convergent, and transform boundaries, and what faults are. Next, we went more in depth with transform boundaries, 2 plates that slide past one another, what offsets are, where you can find transform boundaries, and the effects of transform boundaries. Then we talked about one of the greatest examples of a transform boundary, the San Andreas Fault System. Finally, we went through 2 of the most well-known earthquakes caused by the San Andreas Fault, the 1906 earthquake and the 1989 Loma Prieta earthquake. Here are our sources.
Thank you.